Have you ever struggled with breaking down complex integrals? Do you want to unlock the secrets of integration by parts and breeze through your calculus assignments? Well, you're in the right place. Get ready to demystify this rule and conquer your calculus challenges like a pro. Integration by parts is derived directly from the product rule for derivatives. The derivative of a product u times v would be equal to u prime times v plus u times v prime. Rearranging and integrating both sides gives us the integral of u times dv, that is if we integrate uv prime, and that would be equal to u times v, which would be the integral of the derivative of uv, minus the integral of v du. This is the foundation of the entire method, turning one hard integral into a simple one. Here's the formula again. Integral of u times dv is equal to uv minus integral of v du, where u is a function you differentiate, chosen strategically to simplify the problem, and dv will be a function you integrate, the remaining part of the original integrand. Here's a guideline to choose u. It's called the LIATE Rule. You will choose from whichever category appears first in the LIATE order, where L stands for logarithmic, I inverse trigonometric, A stands for algebraic, T for trigonometric, and E for exponential. The first item in the list gets priority as u. This will keep the resulting integral of v du as simple as possible. In this first example, we'll integrate x times e to the power x dx. We'll let u be equal to x, and dv has to be the remainder of the integrand, which is e to the power x dx. In order to get du, we'll differentiate u. So du will be equal to 1 times dx, and in order to get v, we'll integrate dv. The integral of e to the power x dx is e to the power x. Now we can apply the formula step by step. The integral of x times e to the power x dx is equal to u times v, so that's x times e to the power x, minus the integral of v e to the power x du is dx, which is what we have here. So we can rewrite the first part, x e to the power x, minus the antiderivative of e to the power x with respect to x is e to the power x, and then plus c, never forget the constant of integration. We can simplify this answer by factoring out e to the power x, so that will become e to the power x times x minus 1 plus c. Example number 2 will integrate ln of x dx. We can rewrite this as integral of ln x times 1 dx, and then apply the method. By the LIATE rule, u will be our logarithmic function ln x, and dv will be the remainder of the integrand 1 dx, or simply dx. Differentiating u to get du will be equal to 1 over x dx, and integrating dv to get v will be equal to x. Now we can apply the formula. U times v would be x times ln x, minus integral of v du will be integral of x times 1 over x dx. This second part, x times 1 over x, simplifies to 1. So now we can write our final answer. That will be x times ln x minus the integral of 1 with respect to x is simply x plus c. Now let's take it further. We want to integrate x times sine of x dx. By the LIATE rule, algebraic comes first. So we have an algebraic term x and a trigonometric term sine of x. So u will be equal to x, and therefore dv has to be the remainder of the integrand. That will be sine x dx. The derivative of u will be simply 1 times dx, because that's the derivative of x times dx. And if we integrate dv, we can find v to be negative cosine x. Now we can apply the formula. U times v is negative x cosine x minus the integral of v negative cosine x times du, which is dx. So that will be equal to negative cosine x minus a negative becomes plus, and the antiderivative of cosine x with respect to x is sine x plus c. Integration by parts turns a difficult integral into a simpler one. Remember the formula. Integral of u times dv is equal to uv minus integral of v du. Master the formula, choose u wisely using the LIATE rule, and even the most intimidating integrals become approachable. Thanks for watching. Please like and subscribe to keep learning with us. And don't forget, math success starts when you stay on the fast track.